Hi dear students, today we are going to talk about natural consequence of the high specific latent heat of ice and steam. Okay, so first of all we are going to discussing natural consequence of high specific latent heat of ice. So first one, soft drink bottle cool better in ice than water at 0 degrees Celsius. It is because every gram of ice at 0 degrees Celsius, okay, extracts out 336 joule of heat energy more than water at 0 degrees Celsius, owing to high specific latent heat of ice. Okay, and next is weather becomes warm during snowfall. Weather becomes warm during snowfall. It is because every gram of water at 0 degrees Celsius on freezing gives out 336 joule of heat energy. Owing to high specific latent heat of ice, as every large amount of heat energy is released, the weather becomes warm. Okay. And next, weather becomes very cold when snow starting melting or the hailstones start melting. It is because every gram of ice at 0 degrees Celsius requires 336 joule of heat energy from the surrounding on melting to form water at 0 degrees Celsius. As vast amount of heat is extracted out from the surroundings, it becomes very cold. And the fourth consequence is glaciers spread reverse flow throughout the year. Ice on glaciers melts slowly as every gram of ice on melting to form water at 0 degrees requires 336 joule of heat energy. Summer or winter, the ice on the glaciers does not melt completely. Thus, such rivers flow throughout the year. Okay. And the next is icebergs sometimes reach equatorial regions in the sea. Icebergs sometimes reach equatorial regions in the sea. Ice has the highest specific latent heat capacity of 336 joule gram inverse. Thus, when a large sized glacier is picked up by ocean currents, it melts slowly because a huge amount of heat energy are required to melt it. In such a situation, some big icebergs manage to reach equatorial regions. So these are the some consequences of high specific latent heat of ice. I hope all of you get the idea about natural consequence of high specific latent heat of ice. Okay, thank you.